Hi students, today we are going to deal with the chapter of three-dimensional geometry in 12th. It's an important chapter, okay? So before starting this chapter, we can go to the topic of direction cosines. What's the first topic? Direction cosines. Three topics has been removed from this chapter already. So direction cosine means, I think 3D means we are having three axes, x-axis, y-axis, and a z-axis. So direction cosine means let L is a line. L is a straight line which passes through origin. Assume a line L is passing through origin. Okay, you can imagine that one. We're having origin. Origin means the coordinate will be 0 comma 0 comma 0. So a straight line is passing through that origin 0 0 0. You can see that L, that line which is passing through the origin, makes an angle alpha with x-axis. It makes an angle of alpha with the x-axis. L makes an angle beta with y-axis. And that same L makes an angle of gamma with z-axis. Is it okay? We're having a straight line which passes through origin 0 0 0. That L makes an angle alpha with x-axis, beta with the y-axis, and gamma with the z-axis. I think it's clear. Okay, fine. After measuring those alpha, beta, gamma, let me evaluate the cosine of those angles. Let me find cos alpha, cos beta, and cos gamma. What is alpha? Alpha is the angle made by line with x-axis, beta with the y-axis, gamma with the z-axis. After finding or after measuring alpha, beta, gamma, let me take its cosine values. That is cos alpha, cos beta, cos gamma. This cos alpha, it will be a value. It is denoted by L. Cos beta is a value denoted by M. Cos gamma is another value denoted by N. So cos alpha is L, cos beta is M, cos gamma is N. And there is a relationship between them. So you can see that this cos alpha, cos beta, cos gamma, they are known as direction cosines. So this name indicates it is cosines, right? So direction cosines, cos alpha, cos beta, cos gamma are collectively, or they are known as direction cosines, and those direction cosines are denoted by the letters L comma M comma N. So L is a direction cosine, M is a direction cosine, N is a direction cosine, and there is a relation between them. When you add them, after squaring, you be getting 1. So L square plus M square plus N square is equal to 1, or L square you can write like cos square alpha plus cos square beta plus cos square gamma. It is equal to 1. I hope it's clear and you are okay with the concept of direction cosines. Okay. Now let me move to the term of direction ratios. Direction ratios. I think already you know what I mean by direction cosines of a line. Direction ratios are also some numbers. They are some numbers related to a line. They are the numbers related to a straight line in 3D. Those numbers are not only numbers, those numbers, direction cosines are the numbers which are, that's important point, which are proportional to direction cosines. So you know what you mean by direction cosines, LMN. So any numbers, any set of numbers which are proportional to direction cosines are known as direction ratios, which means I can write, and also I can tell you that it is denoted by direction ratios are denoted by the letters A comma B comma C. Direction cosines was related denoted by the letters L comma M comma N. Here it is direction ratios which are proportional to direction cosines are denoted by A comma B comma C. Proportional means, as you know, L divided by A will be equal to M divided by B, which is equal to N divided by C. In the case of direction cosines, there were a relation of L square plus M square plus N square is equal to 1. In this case, that relation is not there. So that's about the direction ratios of a straight line. I think it's clear for you. Okay. Now, next topic, direction ratios of a line. Direction ratios of a line when if 2 points are given. If 2 points are given, we have to know how to find the direction ratios of a straight line. Okay. Now listen. You assume that you're having a straight line with you, and that straight line is having 2 points. A is given as x1, y1, z1, and what is b, x2, y2, z2. So this straight line is having a direction ratios. We know that one. So direction ratios can be denoted by the letters. As I told you, it is A, it is B, it is C. In this topic, we are going to learn how to find this A, this B, this C if 2 points are given. A is given by x2 minus x1. Very simple. B is given by y2 minus y1. C is given by z2 minus z1. I hope it's clear for you. A is equal to x2 minus x1, B is equal to y2 minus y1, C is equal to z2 minus z1. So we learned how to find the direction ratio of a straight line if 2 points are simply given. Next topic is a relationship between direction cosines, and direction ratios. We are going to deal with the relationship between direction ratios and direction cosines. You listen here properly. It's very easy. L is given by plus or minus a divided by root of a square plus b square plus c square. In the previous case, we have learned if you are given 2 points, we can easily find a comma b comma c. Now in this topic, we are discussing after evaluating a comma b comma c, how to convert that one into L, M, and that is the meaning of relationship between direction cosines and direction ratio. So M is equal to plus or minus b upon root of a square plus b square plus c square. N is equal to plus or minus c divided by root of a square plus b square plus c square. So this is L, M, and relationship between direction cosines and direction ratio. So this is also very important. Now we are discussing equation of a line. From now onwards, we are entering to the chapter. Okay, the other topics, the previous topics were only basics questions, like basic concepts only. Now we are going, or we are moving to the main topics of the chapter. Equation of a line in 3D, or in 3D, yeah, in space. Equation of a line in 3D. Okay, fine. Listen here. I told you from here we are beginning the chapter. We have learned in grade 11 regarding how to find the equation of a straight line in 2D. Today in this chapter, we are going to discuss how to find the equation of a straight line in 3D. So always equation of a line in 3D, we are denoting in two formats. In most of the cases, two format: vector form and Cartesian form. So we are going to deal with the equation of lines in 3D. So we will discuss equation of a line in 3D in two formats. The first format is vector format and the second is Cartesian format. I think it's clear for you. Okay, we can discuss like one by one. So the first case, when a point comma, a parallel line is given. Important. Listen. So assume that you having a line with you. It's very easy. Topics are very easy. Very easy. Just listen. You having a line L. That line is in 3D. We need to find the equation of the straight line. You are given one of the point on that straight line, which is given by x1, y1, z1. A parallel line is given means another line is given. That line is parallel to this required line. So let me denote that line with a vector. Assume it's a vector, vector b. Okay, that line is not in a vector format like a vector b. So let be equal to example ai bj ck. So that vector b is equal to ai plus bj plus ck. We know that a straight line in vector format can be denoted by like generally xi, yj, zk. We have learned that one in the chapter of vectors. So b is a parallel vector. B is a parallel vector. It have given like parallel line, but as in vector form, I can tell that it's a parallel vector. It's a parallel vector is given by ai plus bj plus ck. I hope it's clear for you. Don't be confused with this one. This b and this b are not same, they are different. Okay, so vector b is equal to ai plus bj plus ck. Now we need to find, as I told you, we need to find the equation of this straight line L. What we are having with us, we are having one passing point x1, y1, z1, and we are having a parallel vector given by ai plus bj plus ck. Now let me explain the equation of this line in vector format first. In vector format means, listen, it's very easy. R is equal to, vector R is equal to a plus lambda b is the equation of a straight line satisfying this condition in vector form. So obviously you'll be having some doubts. What is R said? What is A said? And what is B said? R is a general point xyz, which means vector R is simply denoted by xi plus yj plus zk. Okay, fine. Vector A is the position vector of the passing point. What is vector A? Position vector of the passing point. What is the passing point here? Passing point is x1, y1, z1. So x1i, y1j, z1k. That is what? Vector A. Vector B is nothing but the parallel vector, which I give to you directly. Vector B is what? Parallel vector. Already we have given that. Parallel vector can be given like ai plus bj plus ck. That parallel vector you can write instead of b. And lambda is a constant value. So this is the method of finding an equation of a straight line L whose passing point 1 is given x1, y1, z1, and that straight line is parallel to another line vector B, which is given by ai plus bj plus ck. So equation of L in vector format is given by R is equal to a plus lambda b. Here itself, let me discuss about its Cartesian form. It's very easy. So Cartesian form of this case is given by x minus, x is normal x, okay, x1, this passing point, everything is there, divided by a means this a, coefficient of I, which is equal to y minus y1 by b, this b means coefficient of j, which is equal to z minus z1 by c, this c means coefficient of k. So this is the Cartesian format of this one. So these two cases are important. So far we discussed what are the topics already we discussed. Let me revise it again. We started with the direction cosines. Direction cosines means they are the cosines of the angles made by a line with the x, y, z axis. So let L makes an angle of alpha with x, L makes an angle of beta with y, and L makes an angle of gamma with the z. And cos alpha, cos beta, cos gamma are known as direction cosines. Cos alpha can be denoted by L, cos beta can be denoted by M, cos gamma can be denoted by N. So the relationship between them is given by L square plus M square plus N square is equal to 1, or cos square alpha plus cos square beta plus cos square gamma is equal to 1. Now we discussed about the concept of direction ratios. What in by direction ratios? Numbers related to a line, those numbers are proportional to direction cosines. They are denoted by a comma b comma c. L by a equal to m by b equal to n by c. Now, how to find direction ratios of a line if 2 points are given, x1, y1, z1 is a first point, x2, y2, z2 is a second point. So a is equal to x2 minus x1, b is equal to y2 minus y1, c is equal to z2 minus z1. Now, after this one, we have learned or we have discussed about the relationship between direction cosines and direction ratios, which is given clearly here. You can learn it. After that, we are discussing or we are going to start the discussions of equation of a line in 3D. In two formats, we can represent the equation of a straight line. First one is vector form and second one is Cartesian form. The first type we discuss here, it's very easy. In this topic, we are discussing how to find equation of a line in 3D if you are given a point on that line and also a parallel vector or parallel line is given. So I drew the figure and I told you that vector format of this case is given by r is equal to a plus lambda b, where r is the general point xi, yj, zk. A is the position vector of the passing point x1i, y1j, z1k, and b is the parallel vector lambda is a constant. And its Cartesian format is x minus x1 by a. X1 is there, a is the coefficient of I, and y minus y1 by b, b is their coefficient of j, y1 is given, z minus z1 by c. So this is the Cartesian format. Okay, so learn till here. The rest of the topic we will discuss later.